Tutorial number 3. As shown in figure 9, an irregularly shaped object weighs 40 kg in air and 25 kg when fully submerged in water. Determine the volume and specific gravity of the object. So in this situation, I think you could imagine that in air, if you measure the weight of a certain object, so it will give you certain amount. For example, in this example, it gives us 40 kg. However, if the same object fully submerged in water, we found that the mass here is reduced. For example, in this situation, it is reduced from 40 kg to 25 kg. So it is not a magic, because the reduction of the mass here, because there is a force of buoyancy here that help this object upward like this one. So means that it move outward like this one, and then it will give the mass here, it will reduce the reading of the mass here. So means that the existence of force of buoyancy here change the amount of mass in when this object submerged fully in water. So and then we could make a simple equation. So for example, in air here, we found that the weight is actually equal to mg, and it's equal to rho g and volume. So please bear in mind, the rho here is actually the rho of that object, and then gravity and the volume is the volume of that object. So and then in water, okay, so we could find that weight in water, it is equal to weight in air minus with the force of buoyancy. So this is what I explained just now. So we have a 25g, it is equal to 40g minus rho gv. So here the rho gv here is actually the volume of displaced water, displaced volume. Okay, so and then according to this calculation, we could get that the volume, the value of volume is 0.015 meter cube. So and then the question is, what is the specific gravity of this object? So we know that specific gravity, as we learned in previous chapter, it is the density of a specific object divided by 1000 kg per meter cube, which is the density of water at 4 degrees Celsius. So if we do this, we found that the SG is equal to 2.667. Please bear in mind that specific gravity do not have any units. So it is a ratio of density between specific object with water.